Okay, hello. Before I start, may I check if you guys are hearing me clearly? Thank you. Right. So since the speaker is also here, right? Greetings, everyone, and welcome to today's webinar entitled "LiDAR Scanner Profiler" by Vertex. On behalf of PCSS, we are excited to have all of you today with us as we dive into today's session. My name is Angelina, and I will be your host for this afternoon session. Before we begin, let's go over a few housekeeping details to ensure a smooth and engaging webinar experience for everyone. First and foremost, please be informed that this webinar will be recorded and it's for future viewing and to distribute to those who are unable to attend today. Secondly, we would like to request all participants to keep their microphones muted throughout the webinar, and this will help to minimize background noises and ensure everyone can hear the speaker clearly. Thirdly, please feel free to drop your questions in the box throughout the session. We will do our best to address them during the Q&A session. And thirdly, attendance will only be shared through the QR code at the end of the session together with the feedback form. So do stay with us at the end of the session to be able to scan the QR code. Before we begin, I would like to do a little bit of introduction of PCSS and um, APTT. PCSS is a project management solutions provider focused on enhancing organizational profits through the implementation of industry-leading practices. Uh, we specialize in digital construction, covering BIM for the simulations, optimization tools such as drones, AR, VR, to name a few. So this emphasizes our dedication to staying technologically advanced and providing innovative solutions for the digital transformation of the construction industry in the region. And as for FPTT was established since 2020, December 2020, by a group of Sarawak professional technologists from multidisciplinary fields of technology and industry in Sarawak, with initial aim to gather all professional technologists and certified technicians from all over the state. FPTT worked together closely with MBOT to ensure sustainability and quality professional development that enable professionals could contribute to the Sarawak economy and development of the country. The PTT takes pride to assist MBOT in recognizing industry professionals in the state of Sarawak. With that being said, I believe we're set for an informative session. Now let's go back to the main event. Ladies and gentlemen, our speaker today is Muhammad Muzamil bin Salahuddin. He is an engineering professional with a background in environmental science from University of University Putra Malaysia and environmental and process engineering from Heilbronn University, Germany. Over the years, he has gained experience in project engineering, research, and sustainable infrastructure, working on areas such as pavement diagnostics, environmental studies, and digital integration. Currently serving as a product engineering manager at Vertex, he contributes to the project that combine technical innovation with practical solutions for climate resilient infrastructure. Mozambique values continuous learning, collaboration, and the opportunity to translate technical knowledge into meaningful outcomes while staying grounded in his personal interests in heritage, travel, and sustainable practices. So today's topic will be is regarding LiDAR. So we know that LiDAR has been around for decades. So what does LiDAR scanner profiler from Vertex has to offer? Yeah, let's hear it out from our speaker today, Mozambique. So the floor is yours.
Hi, Adrina. Hi, everyone. Is my mic okay? Is it clear?
Yes, clear.
Yes. Okay. So before I start, thank you for the kind introduction. I think first I need to just share my screen, right? Let me just quickly
Yes.
do that.
Yeah, please proceed.
Yep. So is it, can you guys see it, the screen?
Yeah, it's on full screen right now. Yeah.
Now it is my full screen.
All right.
So I hope everyone is still have the energy. It's quite late in the week and it's 3 p.m. So I'm not sure. I think Angelina has explained that we are gonna have a Q&A session right after the presentation. So I think taking note during presentation and then you can ask me at the end of the presentation. So Asian Vertex. So I've been working at Asian Vertex for almost 3 years. So what's attracted me to the company because the company deals also always with innovative solutions. So the latest motto that we have right now is pavement materials and engineering solutions. So a little bit of background about the company. It is founded in 2015. So this year is going to be our 10 years anniversary. Teams of 156 personnel and growing. So in about of 250 years of combined experience, we have lots of young energy, combination of young and experienced personnel. Our core business was pavement materials, but nowadays because we are in strategic positions in Malaysia and also in JKR with the highways and everyone, we want to expand. Yeah, we are expanding to PCA or pavement condition assessment. So because our motto is innovation, we're always looking for the latest technology that is available in the market in the world and to bring the technology into Malaysia. So this is our team. Is leaded our leader or the chairman is ex-director, deputy director of JKR, Datuk Haji Zul Kamal bin Sufyan. So if you see on the left hand side, I'm under Dirk Quinton, under new business and technology. This is where our our team is will look for always for new technology, new technology or innovation that we can bring into Malaysia to introduce to in the industry. Also, what we can do in our company is engineering services and also design. We can do design of pavement of ourselves and operation and project and supported by our finance and also HR. So the mission of the company is to always provide innovative, quality, cost-effective and sustainable products and solution to the infrastructure and construction industry. So before at start, we are not limited. Our focus was on pavement materials, which is I don't know if you are familiar with super fiber mix. It is from Asian Vertex. So it is I think one of the best special mix material in Malaysia. So right now we want to use that position to bring in new technology, the one that I will be introducing today, LiDAR scanner profiler. So our vision is to be recognized as a market leader in Malaysia, not only in Malaysia, but also in Southeast Asia, as the innovative and high-tech solutions provider. I apologize a bit for my voice. I was a bit under the weather this week, so I hope it will be clear enough for you guys to understand my presentation. So we have 5 products, as I said. Engineering, the LSP or LiDAR scanner profiler goes under the engineering services. So these are our products. Lots of them I know, but today we're going to be only focusing on one on the right hand side, LSP. On the left hand side here are all pavement materials, number 1 to number 4. And number 5 is actually one of our might hobby, glow in the dark paint. It was viral quite a while ago because we were the first one who brought the material in, the best one in the world, into Malaysia. But because there are some negative vibes concerning the products of other companies that the market is a little bit on the way down. But it's okay. We move forward. We bring in more technologies into Malaysia. One of them is LSP, LiDAR scanning profiler. And maybe some other time I will can also introduce to multi-speed deflectometer. It is also state-of-the-art technology for pavement condition assessment. So this is our clientele that is using our products and also our services so far in Malaysia. So let me straight away jump into the slides. As you can see, quite a number of slides that I have in my presentation. I think it's slides 162. So I just want to check again. Is it okay that the screen is showing, Angelina?
Yes, it's in full screen.
Is it full screen?
Yeah.
Okay. Generally, I want to start with payment condition assessment. So in Asian Vertex, we have brought in two technologies. The one on the top, MSD, one on bottom right is LSP, or here. LSP basically surveys or we capture data on the surface of roads. So we are using LiDAR technology. We are using all the positive and the characteristic of LiDAR technology to capture surface data. On the right hand side, we have multi-speed deflectometer. That is to investigate or to find out, capture data for the structural condition of the pavement. What does it mean by structure? It means that everything underneath the pavement surface. So it is special that way. If you are familiar with falling weight deflectometer, the one right in the middle, this is the conventional way to investigate or to collect data about structural condition. But MSD is the latest technology. But maybe if I have some time, I can maybe explain a little bit. So GPR and DCP are conventional ways to also to collect data. So going directly into the main topic of today, LiDAR scanner profiler. So it's a bit weird because I don't hear anything from the because usually when I do presentation, I will hear some feedback. So I'm not sure whether I'm talking alone or is there any question that the audience want to ask me. So it's all right. So I'll just jump straight away to what LiDAR scanner profiler is, LSP. That is the acronym, LiDAR scanner profiler. It's a LiDAR based technology. What it does is it scans, and when from the scanner we get the profile data of the road. So LiDAR scanner profiler. So it is the cutting edge road scanner profiler because it uses the LiDAR, the latest LiDAR technology. As you know, LiDAR has been around for many years. Usually we can see LiDAR on drones, on planes, on sometimes even now on bikes. But this product brought in from Belgium, from Xenomatics, it is powered by the latest LiDAR technology, also with AI, which I will explain later, how AI helps this technology to get the results faster. And also latest GNSS with RTK. So when we talk about GNSS, we are actually talking about the GPS, the the location technology. So sometimes when you use phone, for example, we have the accuracy GPS of maybe 3 meters to 5 meters. But with RTK, we improve the accuracy to 2 centimeters using RTK. So that is quite impressive for the profiler for this kind of work. And a complete digital twin of the road. I'm sure you all are familiar with digital twin. What does it mean? So LiDAR is able to do that. It is able to give you the digital twin of roads. This is the first profiler that can do that. And the results can be visualized in a GIS software. So it is any GIS software can be used to visualize the result from LSP. So when you're talking about main features, first of all, it must satisfy or you must give the data that the conventional profiler gives. First is IRI. Uh, what is IRI? IRI is International Roughness Index, which will tell you how rough the section of the road is. So the higher the data or the value, the more uncomfortable the ride will be. Rutting is actually the the horizontal surface of the road. So the same thing, the higher the rutting, the bad the worse the road is. Crack, as the name tells, you don't want more cracks, you want less cracks. So this machine can detect cracks. Macro texture is about the skid resistance of the road. It will tell you about the condition of the road using macro texture. And the number 5, 3D digital twin of roads using GIS-based data. So I'll explain to you a little bit how the data is, each of the data in the point cloud is GIS-based, and you can upload it in or visualize it in any GIS software. So on the left-hand side, you can see we actually install it on the local car. it can be installed. One of the advantage of this LiDAR scanner profiler uh, in comparison to the conventional one, I don't know if you are familiar with the conventional profiler. They can only be installed on this big macam I think like big van. So it must be big, and then the wiring is going to be complicated. But on this technology, because it's LiDAR, it's simple technology. You have to just put the sensor up there, and we actually can install it on any car. So we have chosen Arus, our national car, to use LSP. So area scanning, what does it mean? Area scanning is different from line-based scanning, from conventional profiler. Area scanning, the LiDAR will shoot around 28,000 per data per point cloud. 28,000 is around the width is about 4 meters, the length is about 2 meters. So in a second, it can capture 50 times, which means almost 1 million points in a second. So it's very impressive, the amount of data. The big data that the LiDAR is collecting will tell us about the surface condition of the road. So LiDAR sensor on board, groove and crack detection, it is usable because this LiDAR data, the point cloud data, is very useful for us, especially for the engineers, to tell the condition of the road surface, to to help us manage or to help a plan with the road rehabilitation plan. So what is the additional features of this LSP or LiDAR scanner profiler? It's one person operating system. It's very easy to use. If you have the chance, maybe in the future, to work with us, or maybe come to our demonstration, it's very user friendly. All you have to do is press start to do the survey, and then it will collect all the data that you need automatically. The data collection are all fully automated, and the data processing are done locally. It means during the survey, we'll collect the data and save it in a hard disk, SSD. And right after the survey, we just transfer the SSD into a X station, we call it, the processing computer, and we'll do the analysis over there, local. We don't need to upload it into clouds or this, so into clouds or anything. So it's faster that way. High accuracy centimeter level. This is what I explained earlier, because we have RTK, real-time kinematics. What it does is this LiDAR LSP will shoot the signal to the RTK tower by Japan, also to the satellites. This enable this 2 centimeter accuracy for each point cloud that we've collected. ETCM vertical range because of the LiDAR, and also no minimal driving speed. This is one of the weaknesses of the conventional profiler. It cannot go below, if I'm not mistaken, 20 or 30 kilometer per hour. It means that for a survey, you have to really plan your survey. You have to have a vehicle behind you, so to make sure that there's no stop. Because if you stop, it will mess up with the data that you collected. But there's no such problem with LSP, because it is area scanning data collection. Even if you stop, there will be no problem. So how does it work? So as you can see, as I explained to you before, 28,000 per point cloud. Lots of laser, lots of data, lots of laser. This area scanning, it will be scanned behind the car. The first number one is recording step. You see, this is about the width is about 4 meter. The length is about 2 meter. So after the recording step, it will put it into the software. The software will translate it into this height map. We call it height map. What does it mean is, if you see the surface, the green means is the same height of the plane. Red means like it's a little bit higher if ada road curbs, and blue and pink means a little bit lower, macam there's a drain or potholes. Yeah, so LiDAR are able to detect all those stuff on roads. So it's also LiDAR is kind of unique in comparison to camera. For example, camera we need light, but LiDAR doesn't need light. It is independent from ambient light condition. So as a result, you see with this, we call it digital twin. So it's like a very accurate presentation or visualization of your roads. So these all data, the dimensions you can measure, and the heights can be used to plan or your rehab program. So this is the example how it looks like in the GIS software. You have this Google map. This is, for example, your road, the road in Sarawak, for example, in Kuching, and then you have this road in the residential area. You see, as you can see, this green means that it's quite quite okay. I mean, it's quite flat, but you have these blue spots means that on the side of the road is there's already the height is already on the lower side. So other we call it some depressions. So and also the line in the middle is actually showing the parameters that I've explained at the start of the presentation, the roughness index or the rutting or the macro texture. So what LSP is able to do is first we call it we always the term that they use is 6 dimension. What does it mean by 6 dimension? 3D geometry. So as you can see in the this picture, you can clearly see that it is cobblestone road. Even though there's no picture, even though you're not looking at any picture, you can like guess that it's a cobblestone road because of the accuracy of the LiDAR. The height accuracy of the LiDAR can go up to 0.5 millimeter. This means that any change in the y or the z axis or in the height can be detected by the LiDAR. That's what makes LSP so useful for PCA. The middle one is the intensity. So when the laser goes to different of material, it will be reflected or reflected differently based on the different materials that it falls onto. So for example, road marking, it will be much brighter than, for example, the asphalt. So this feature is very useful for you. For example, if you want to measure the road marking, you can also determine the relative condition of the road marking in terms of whether it is still in good condition or not. And lastly, the 2D HD image. At the side of the LiDAR sensor, there's a high definition camera. What this camera does is do its two things. So one, it will confirm all the data that we have collected from the LiDAR sensitive. For example, from here, you can see that the actual picture is here. And in the smaller on the right hand side corner, you can see that actually the camera we will also use for crack detection. So that one I will be explaining later how the data or how LiDAR as kind of profiler detect cracks. All right. So the LiDAR scanner profiler, the machine will take picture for every 3 meters. So from every the pictures that are taken every 3 meters, there will be some overlap. So of course there will be some overlap. So that's to avoid any missing points on the road. So from this raw image, it'll combine with the LiDAR, the point cloud, and the AI will help identify the cracks. So what it does is every single line of this crack will be detected and inventorized in the system. So it is super accurate. It's like if you compare it to conventional, sometimes they do it manually and they can be very subjective in terms of cracks. So it can be tedious, especially for crack detection. But for this system, it's all automatic. It's using AI. From these cracks, we can differentiate 4 types of crack: longitudinal, transversal, alligator, and block. So these cracks will be inventorized, and we can see it in an Excel table. All single crack, semua ni ada, each of the crack is ID, ada ID. They have identification. Number 1, number 2, number 3, sampailah even how many thousand cracks we have on the road. So we collect all of them. We'll detect all of them. And then also, of course, we can, from the inventory, we can categorize based on the severity of the cracks. As you can see from the color coding here. So it's actually talking about the severity of the cracks. So this table is a comparison side to side comparison to the conventional road profiler. Number 1, as I said, road profiler, the function is you have to be able to measure IRI, crack, rutting, and macro texture. That is standard PCA reporting. Laser scan or LiDAR scanner profiler can do that. LSP can do that. So digital twins, model of roads. This is for visualization of roads. Previously, with conventional profiler, in a report, you receive like the booklet or big book of reports, hundreds of pages. So sometimes it is hard to visualize which part of the road You have to know specifically which section, kilometer 1, kilometer 100, kilometer 100 to 1.5. So this can be really, really challenging, especially to the new ones. So when we display or visualize all these results in a GIS map, it will be really clear. You know where the location is because it is very familiar with the GIS, with the GIS map. Data collection and resolution. For the conventional, there is no digital twins, as I explained, but the image are collected also by the profiler, but no intensity, of course. We know about the surface condition of the road, but no intensity and no digital twin. Minimum driving speed, conventional road profiler can go minimum to 20 km per hour. They cannot stop, so they have to plan their survey carefully. But for LSP, LiDAR scanner profiler, we don't have any problem with that. We can stop anywhere we want, so there's no issue with that. In terms of easily handling height accuracy deactivation, minor grooves of profiles, as I said, the Z accuracy of LSP is 0.5 millimeter accuracy. I'm not sure about the road profiler. Easy handling operation, as I know, I was informed by the MLP or the profiler company that there were at least 2 or 3 properly trained personnel. But for LSP, it's so easy that even that guy that doesn't know how to do the survey, you just need to know how to drive. You go into the car, you just press the start button for survey, and you collect the data, and then you press stop at the end. That's all. The advanced technology of georeferencing data location, the LSP used the combination of RTK, GNSS, and MMU, which means higher accuracy to 2 centimeter level of accuracy. GNSS, MMU, it depends on the GPS technology that they use in the system. A more expensive one, maybe you will get around 1 meter or half a meter. That's talking meter level, but RTK you get centimeter level, so it's really, really accurate. Outages, for example, in tunnels, because of the advanced algorithm of the machine, it can go into tunnels. Doesn't have any issues with tunnels, even up to 5 kilometer. Equipment installation of vehicles, it can be installed on any SUV, any van, any MPV. As I said, we on our in the Asian Vertex, we install it on Arus. We can do it on any car, but we choose Arus. But for LSP, it usually comes with from the supplier in a specialized purpose vehicle, SPV. So because it's the wiring can be complicated and the sensor can be really heavy, so we have to put it on a big vehicle. Detection of cracks, because of the AI, it actually increased the productivity of the analysis. And also, I was informed that for conventional profiler, especially when if you do manual, you're going to need 3 to 4 teams to manually subjectively classify cracks. This can be one, time consuming. Number 2 is can be the results can be not objective, it's subjective. Understand, sometimes human someday you feel okay and then you give this crack score a bit lower, and when you're not feeling okay, you might give the crack score a bit higher. So this is not objective, not good for road condition assessment, especially. Asset inventory, it is one of the modular that we can add to the machine. We will put a 360 GIS scanner on top of the vehicle. I think when I was actually with PCSS in Indonesia, in Jakarta, I was talking to Mr. Andy Tiong. We talked in depth about this. So we try to integrate BIM or GIS into this system. As I've said, the processing is fully automated. We do it locally in our local computer X station, and the output is compatible to any GIS software. So for visualization, for easy visualization, and also can be used for HDM4. So after that, so when we talk a lot of stuff that I've explained about digital twin, what is it useful for? What is it used for? So this is one of the application that we can use. So right after you completed a new job, right? This is a new road. So you want something, a report that's very tangible that you can use to support your claim that, for example, the road is bad. The new road is not as good as it should be. So you run the LSP, less than a minute drive, depending on the length of the road. For example, here, you can straight away see that from the digital twin, as you say, from this picture, there's green before the road before the new road section, and then this bump, the grooves, the blues mean that the roads are slightly lower than the green, and this can be serve as a report or a support for you to show the contractors or to show the GKR, to show the asset owners that this work is not properly done. So this is one of the use. It's very easy. This one you can do it like you survey, and the analysis can be done maybe 10-15 minutes because this is pretty straight away. Another one is kind of, when we introduce new technology, of course, we have to compare the reliability of the new technology in comparison to the old one. So the tests have been done in the USA. National Center of Asphalt Technology, they are very famous in Alabama. So this proves that both are actually returning the same results. So this is the picture that actually the internal run that we did at FT004 Greek Jelly. If you guys still remember, there was this big bus accident that happened in this road, I think a couple months back. So they actually did the survey right before that. So we have the data of the road condition in that accident location. So this actually shows that PC really important to assess the condition of the pavement condition and to help the KR or to help the asset owner determine whether which part of the road need to be fixed first, which part of the road need to be prioritized for repair or rehabilitation program. So in conclusion, what LSP can do is it measures IRI, rutting, macro texture and crack. So everything that the conventional profiler can do, LSP can do it. But LSP is a more high resolution system. The point cloud, if I haven't explained, is actually 5 millimeter times 5 millimeter. Is really accurate. And then the results are highly repeatable as shown in the test done by the NCAT. The positioning accurate, exceptional accurate positioning results from the RTK means that the centimeter goes up to 2 centimeter level accuracy, which is very helpful, especially in pavement congestion assessment. And also from the data, we got geometry, the intensity, which helps with the road marking, and also the crack detection from the 2D image. The learning AI offers, because AI is a learning tool, it's a learning machine. So when we talk about learning, it means that it will get better with time. So what it means, the processing time will be shorter, especially with the development of more better and better AI. Means that the crack analysis will be more reliable and faster in comparison to the conventional one where you rely on manpower. 4 or 5 people is very subjective. So we don't want subjective report. We want objective report with factual data. And also it's ideal for any type of roads. You can do it on highways, urban, jalan kampung, local roads, in Sarawak, everywhere. Doesn't matter. So I think that's all for LiDAR scanner profiler, Angelina. Maybe is there any, no, I don't know how do we proceed with this?
Okay. Right. Let me. Let me share screen. Give me a second.
Structure. So architecture is bunch of bodies.
I just want to share this result that I have obtained or we have obtained during our internal class at Greek. So in that FT004 project, the official PCA method was the conventional one, the multi-laser profiler. So what we did was we sent our LSP, LiDAR scanner profiler, to also do the scanning, the same exact scan job, PCA job, internally. So we did comparison of the results that we have obtained from MLP, the multi-laser profiler, and also the orange, the LSP. So have you seen from the graph, the R squared, the correlation is very, it's actually excellent. It's beyond, it's almost 90% here. It's almost 90% here for IRI, for MLP. So it gives like, it's gives us a point or something to show to GKR that the technology are reliable. It's a next gen, new state of the art technology that we should use. Because LiDAR, in comparison to conventional, there's no rotating parts on this machine. Let me show you the picture of the system very quickly. Not this. Mm. It's a simple setup. There are no moving parts or rotating parts on the software or on the oh yes, yeah. There's no rotating or moving parts on this system. So it means that the maintenance is very minimal, really minimal. And you see, and it's always the case for LiDAR. It's very reliable in terms of geometry, in terms of the measurement that it takes. Very useful, very reliable, very quick in comparison to camera. Nowadays, we have heard a lot about people doing survey with cameras with high definition cameras. It will take a lot of processing time because with cameras we have a lot of details, but with LiDAR, because it's points for the computer, just points for the computer to process, so you can process really quickly. Because that's why with our system, as I said, when we do the survey in the morning, in the afternoon, can already get the results from the survey, so it's really quick. Okay, Gina, please proceed.
Okay. Okay. Ladies and gentlemen, as we reflect on the possibilities unveiled during the presentation, let's move on to the Q&A session. Um, so let me open up the first question regarding this
Yep.
all this LSP. So how far has this LSP technology been adopted in Malaysia?
So in Malaysia, officially, we have not done any projects yet officially, but unofficially, for example, at Greek, the FT004, we have done survey for almost 300 kilometer. And can you guess how many days we need to complete the 300 kilometer survey, Angelina? 300 kilometer,
300 kilometer.
kilometer PCA survey. How many days do
Um,
we need?
I mean, judging by the efficiency, perhaps it's
Mm.
1 week. 1 week.
Exactly 3 days. 3 days. So one day we'll do the survey from 8 until 12. And then in the afternoon, we'll do the data processing. And then the next day, we'll do the same thing. We repeat it for 3 days. So one day, we do around 100 kilometer. So we can complete 300 kilometer project in 3 days. So it's really quick. It's really, because the LiDAR technology, it uses this, as I said, point cloud is very simple for the computer to process. So that's why it can be really fast.
So, to follow up with that conversation,
Mm.
how if we still use the traditional method, how long would it take to do for the 300 kilometer?
Okay, for the 300 kilometers, usually you are doing now, because, for example, the team that we hired to do this survey at Greek, because the team is based in Malacca. The company is based in Malacca. So they have to finish first the survey. You have to bring back the vehicle to Malacca, and then I think a day they cannot do more than, they cannot do like we did, because they need another vehicle to accompany them during the survey. As you know, as I said, they can't stop, so they have to do proper planning. We are like driving a normal car, like we are driving Arus. We just driving while collecting data on the road. So I think in terms of their productivity, 300 kilometer, I would say they will collect the data for a week and then a bit, and then they have to do analysis and reporting for another week or another 2 weeks because they have to bring all the data to their headquarters and do the analysis. As I said, crack if they do it manually, and then it will be time consuming. But it's different to our side. Everything is automatic. Everything is done by AI and computer.
I see.
Yeah.
Right. We have also another question from the
Yes.
floor. Right. So, in regards to the difference between the LSP and the conventional method, right?
Mm.
Could you share with us what kind of data that the traditional method might miss when you are doing the scanning?
Might miss.
Yeah, the thing that
Mm.
traditional method cannot really capture.
Okay. When you talk about a pavement condition assessment, there are parameters that actually are there because of the ability of the conventional profiler. It means that the conventional profiler, they are designed, for example, to collect IRI data, routing data, macro texture data, and also the crack data, right? So when I said something that you might miss, they will not miss this. The IRI, the routing, the texture, they can, every scanner should be able to do that, or else the client won't pay for their service. But for example, in terms of crack reporting, for example, yeah, we have done a couple of projects and trials on POC with our clients. Some of the crack reporting are done one way. One company will do it another way, and one company will do it another way. So IRI, routing, and texture are pretty straightforward. You won't miss anything. But in terms of crack, these are the biggest difference and what we see or what I experience in terms of the conventional versus the LSP. So LSP, because everything is automatic, done by computer, we are not subjective. We will take into consideration every crack that is detected. But sometimes when you do conventional method, you do it manually. You rely on pictures, you rely on videos. Sometimes you might miss something. That's the difference between the conventional one and the LSP.
In your opinion, do you think LSP is reliable when it comes to profiling in regions with challenging terrains or dense vegetation along the roadsides?
Dense vegetation along the roadside. Okay. When we talk about dense vegetation along the roadside, it means that you are concerned with the, is it concerning with the GPS signal or the data, the safest roads?
The data.
The data. Because the data is actually pretty straightforward. The Greek, for example, when when I went there, I can even see elephants on the road. So it was pretty outside of the suburb or urban area. I have no phone signal in that location, in some of the location in Greek, but the data that we collected are all good. Are all very useful and usable for our survey and our data analysis. So in terms of location, there's no issue even if you do it in the city or in somewhere far away from the city. There's no issue with that. Uh, I would say it's really reliable because LiDAR is, as I said, I explained, really straightforward. We have to take advantage of this technology and use it in Malaysia.
Right. To further our conversation. So,
Mm,
the first step, of course, we would need to collect the data,
mm,
right? Collect data, then we would be do the processing, and then at the end we will show the results, right?
yep.
So, here's I will the thing that I would like to know.
Mm.
Once like the LiDAR data is being collected, so what are the methods that you use to process and visualize it for future decision making?
Okay. With the software comes with the system comes with the software. So everything that we have collected from a survey will be stored in a hard disk, right? An SSD. So we'll transfer the SSD, the hard disk data, into the processing computer, which has the software inside. So all the software do is this: you will get this raw data from the hard disk and will process. So the estimate is like roughly like this: 1 hour of survey data, you will need around 2.5 hours to analyze it. So if you drive like 5 hours, you're gonna need like 10 or 12 hours of processing data. So you'll do this processing in the computer, and from the processing, you will get this all the parameters that I've said to you before: IRI, rating, macro, texture, and crack. So that's the reporting done in the same day of the survey, basically. So yeah, it's pretty easy to use. The software is also really user friendly. There are advanced settings that the survey or the engineer can tinker with, but the settings are really straightforward and it's not hard to do.
All right. We have one more. Okay, this question from
Yeah.
participant. Yeah. So they were inquiring you
Mhm.
if they could have the slides that you are sharing today.
Yeah,
Would
sure.
it possible?
Yep. I'll share
Hello.
the slides to you, Angelina.
All right.
Hello.
Hi. Yes, Mr. Lim, please proceed with your question.
Yeah, yeah. Sorry, I came in late because Andy just gave me the link, so I missed the big part of it. I just came in. I saw Q&A, but I
Yep.
think you guys I think Andy had just briefed me. You guys are doing the road maintenance and you're doing LiDAR scanning, am I right?
Correct.
So I just want to ask because I have a few potential projects.
Mm.
But it's not in Malaysia. Okay, it's
Mm.
about road maintenance,
Mm.
and the country it's really I would say a developing country.
Mm.
The condition and roads are really quite bad,
Mm.
and the accessibility of the areas are also kind of bad because
Mm.
not everywhere you can drive.
Mm.
Some part you need to ride horse and all this kind of thing. But
Okay.
they are building these roads with maybe 200 km or something.
Mm.
The purpose of why they are building this road is because of the condition of the roads. Yeah. So
Mm.
I wonder if you can bring your technologies to overseas. Is that allowed, or is this your own IP, or yeah, that's the thing I want to ask.
I see. Okay, thank you, Mr. Lim, for the question. So first of all, for developing countries, I think if you have missed my presentation, explain that the technology will use RTK, real-time kinematics. It will rely on the local towers. For example, in Malaysia, we have hundreds of RTK towers that help with the accuracy of our GPS or positioning data system. Maybe in that country we won't have this technology, so the accuracy of the GPS will vary, maybe to 1 meter or 3 meter accurate. But it still will be usable. It's normal for any profiler to have this accuracy of positioning. In terms of accessibility, uh, the LiDAR, for example, in our case, are installed on Arus, right? If you want to have it used in another country, it means that we have to find similar vehicles that we can install it onto, and also to use the technology. For example, to use the technology, yes. But if the road is not accessible, it means the vehicle can't even go in, so it's not
I
suitable
understand.
for our system. Yeah,
There's no
it
way you
must
can
be
do it. Yeah,
yeah,
yeah.
it must be road vehicle
Um,
accessible for us to drive, because the machine will need power. The power comes from the battery of the car, etc., etc. Yeah.
because I will be going there quite soon.
Mm, mm,
To explore this road thing,
mm,
and the probably early November I'll be there. But a lot
mm,
of systems I noticed their
mm,
system they're
mm,
not using the US systems because they're Russian.
mm,
So they have the Russian stuff. And
mm,
I see that the thing also quite very different. I'm not
mm,
sure. I haven't go
mm,
there, but I receive a lot of feedbacks. Yeah, I don't know about I think they told me they use LiDAR drone, so I guess they have their own RTK stuff. Um, they coordinate and other stuff. So I'm not too sure
Yep,
if
yep.
it will be the same, you know. So,
Mm.
would your system also support like Russian kind of system or something like that?
Okay, the system is already like it doesn't actually allow any changes. So it's already done. I mean, what we have is what you have. It means that you can do all kinds of data collection. The system will do it all. But when you mean Russian data collection, it means the output can be accessible in the software. If you're talking about the output, yes, it is accessible. It's very user friendly. The format of the output, you can use it any GIS software. You can the Excel table, you can process it any way you want. But the data from the system, you cannot. Other software cannot use it basically. So you have to
Okay.
process it with the software in house to get the output. The
Proprietary
output
lah.
you
Yeah,
can.
on a proprietary software. Yeah,
Yeah,
understand.
proprietary software.
Uh,
Correct, correct.
yeah. Is this your own IP?
Oh no, no, no. It's from Europe.
Okay, okay.
Yeah.
And before I go off,
Mm,
maybe you can share this with Andy and PCSS because I need this. I'm gonna go there quite soon.
mm.
This is a diagnostic mission on these roads, and also maybe some part of Africa because we have some road project there also on the road maintenance too.
All right.
So that would be great if you can share the information as soon as possible so that I can, yeah, I can go there and you know propose this to them.
All right. Sure. No
Thank
problem.
you.
We
Thank
can do
you.
that.
Okay, all right. Before before we move on to the next question, let me take a look at one more question.
Yeah.
So what is the minimum width of the cracks of on the road that your system can detect?
The minimum width. Yeah. Okay. Right now is on par with the conventional crack detection system. It's about 2 millimeters. The minimum crack width that can be detected automatically by a LiDAR scanner profiler is about 2 to 3 millimeters wide.
So that is the smallest the smallest can get.
This, this is almost as accurate as the a system. We call it LCMS, laser crack measurement system. The system is designed for crack measurement and is almost on par with that system. So it means that it's actually really impressive in terms of accuracy. I think I have some data for cracks that I can show that we did from Jelly. Let me see. Oh, crack, this one on the right hand side. Crack MLP versus LSP crack. You see on the
Uh,
orange. Huh?
can you share your
Well,
slides?
I'm not showing.
Yeah, because I've already taken over this now.
Okay, okay, okay.
Mm,
Can you see now?
yes.
Okay. On the right hand side is showing the MLP, the conventional one, the laser crack measurement system. The system designed for cracks. It's it is special, only designed for cracks, as I said. Even then, the accuracy, as you said, is really comparable, almost 1 to 1. The R square, the correlation is 94%. So it's really high. It's really accurate, even for this, even if you put it toe to toe with the MLP for crack detection. Because this is one of the concern with GKR, because they understand maybe about all LiDAR technology will not be able to do this. But because this system, it it takes advantage of the HD camera images that it took every, as I said, every 3 meters, and also it combines with the LiDAR points, the 5 centimeter times 5 centimeter LiDAR points. That's why it can reduce the accuracy of the crack detection to 2 millimeters using this camera, and also the point clouds combines both for crack detection, so that we can get this crack detection with high reproducibility and high confidence.
Right. Okay, let me come back. Let me share my slides over
Mm.
here. Right. Thanks everyone for your participation in this Q&A session. So, in wrapping up to the session, we've been treated to a session that was both informative and engaging at the same time. A special thank you goes to our speaker today for sharing his very valuable insights. So, do you have any key takes before we end?
Uh, for me, I would just want to say thank you to you, Angelina, and also for PCSS for organizing this webinar. As I said, this LiDAR technology is very new, even in the global market, it's really new. Definitely in Malaysia, the first one, we are the only company that is bringing the technology into Malaysia. We want to introduce innovative and also reliable technology for us, for the road users, for the taxpayers, so that we can enjoy better roads with better PCA. We will have more data that will help JKR and also the asset owners to plan or design the pavement according to this data. No more road rehabilitation just based on your eyes or just based on your experience or just based on the historical rehabilitation works. No, we will rely only on data, factual numbers that shows, okay, this road will need this, that section of the road will need different treatment. So this will help the government, the JKR, use our money, the tax that we have paid, more efficiently, more effectively, and in the end we'll get better roads, safer roads for us and also our next generation. Yep, that's all, Angelina.
All right, thank you. Additionally, we have a moment ahead as we present a certificate of appreciation to Mozamel for his contribution as today's guest speaker. So this is your certificate. I will definitely email it to you,
Okay.
right? So now, ladies and gentlemen, before we conclude our webinar, let's capture this moment with a virtual group photo. With that, I invite the participants to open your camera and we'll take a screenshot. Okay, so I have three slides over here. Let me take one first slide. One, two. Okay. Then second slide. One, two. And last slide. Okay, one, two. Okay. Well, before we depart, we would like to share just quick services that PCSS provide. Um, so if any of you are interested in our demo and services or interested to participate in our trainings, kindly contact us through the contacts below. So currently we have Primavera Physics, we have Synchro and 4D courses. We want to know about more about 4D, and you can reach us out through this email or the contact number displayed. We have also for trainings for BIM as well. This is our context over here. And lastly, okay, to ensure we accurately track your attendance and provide you with e-certificates, we kindly request your participation to scan and fill in the attendance form from the available screen. And lastly, thank you to our wonderful audience for joining us. Your participation and engagement have made this webinar a success. We hope you leave today with a deeper understanding on the LiDAR scanner profiler. Uh, Once again, thank you for being a part of this enlightening session. We look forward to seeing you in our future webinar. So stay tuned with us. We always do webinars every month. Uh, and see you soon.